being quiet has never been a problem of mine. Having said that, I'm up here, the microphone's down here, I'm just going to leave it running, so maybe it'll pick up something and amplify things for people in the back. But in the meantime, can you hear me okay?
Yep.
Very good. All right. Thanks for coming, everybody, this afternoon. I'm going to talk to you about building a multi-access key to the family Melastomataceae, which I have labeled here as being mega diverse. And hopefully in a few minutes you will all agree with me that that is in fact the case. So let's just get started. Why construct keys for the Melastomataceae? There's a few reasons, and we're going to take them one at a time. For starters, the family is species rich. What that means is that the family has about 20 tribes, 19 or 20, has over 170 genera and over 5,000 species. So, I mean, given some of the other talks we've heard today, that's a really huge number of species in this family. So, to demonstrate that visually, I have here a phyllo tree, circular form. And I'm sorry, the resolution is not very great, but what's really interesting about this particular tree is that it bears a striking resemblance to the Death Star, which I think so that's really why I chose this key. Anyway, I digress. The point is, hopefully you can see from the image here that the family is very, very large. So that's one good reason to build a key. Another good reason is the family is mega diverse. So I'm going to cover a few different areas of diversity for the family here. So let's start with habit. Now this first picture you can see here, I don't know if you can tell, but that is the palm of somebody's hand. So those are plants that are small herbs that are short-lived, and they're only a few centimeters long, as you can see. So they're very, very small. Moving up from that, we have some pretty substantial vines in the family, and a little bit more common still, the shrubs, which this is a shrub that's about 1 meter tall. And then here we have a tree that looks to be somewhere between 15 and 20 meters tall. I have read and heard that they get up to 50 meters tall, but I couldn't find any images of one that big. But so you go from plants that are this small, fitting in the palm of someone's hand, to trees that can be up to 50 meters tall, all within the same family. So that's a pretty wide range of habits for this family. Moving on, a diversity of substrates and habitats. So first, most melastomes are terrestrial like this, growing out of the earth. However, the family does make up one of the principal groups of epiphytes and hemiepiphytes. And here we have a picture of a hemiepiphytic melastome growing on a fig tree. So if you look here, that part of the crown is the melastome putting roots down, and then down here is the tree, and up here is the crown of the actual tree itself. So what happened is this plant likely started growing in the tree, in the crotch of some branch, and then is sending roots down to get more nutrients out of the soil. And besides that, you have plants like this one, which are lithophytic. They grow practically on bare rock, and this one is very aptly named lithobium. And if you look at this image here, you can see, just barely, that there's one right there growing on the rock, and there's another one, I think, down in here. And what they do, according to Frank, I just found this out recently, is after the rains come, they flourish and then go to seed and then die off again and wait for more rains to come. But they live their lives right there in the little rock right there. So that's a lithophyte. So here we have some pretty pictures for you. There's a very wide range of floral characteristics in this family, and I want to point out a few of the different ones that you can see in this slide. See, first, morosity is what they call the measure of like petals in a plant. And you can see we have one here that has 3 petals, and we have one with 4 petals up here, and there's 5, and then this one up here has 8, and they go as high as 12, but I couldn't find a good image of one with 12. So there's a really wide range of petal numbers. And besides that, the number of stamens, which are the male parts of the flower right here, you can see this one has 3. And since it has the same number of stamens as it does petals, that's a state called haplostaminous. And that's a little bit more uncommon. The rest of these are diplostaminous, meaning they have 2 stamens per petal. So you can see most, like this one has 8, and so on and so forth. Also note the variety of colors. There's more colors coming, but you can see they go from like a nice like kind of magenta to white to red to yellow, and then there's some actually have green petals. We'll get to more of those in a moment. And another diverse characteristic here is the morphology of the stamens. A lot of them are isomorphic, like this one here. All the stamens are the same size. And that's true of a few of these, this one here, that one. But a couple of the other ones, like this one down here and this one up here, are dimorphic, meaning some of the stamens are smaller than the other. So that's just another point of variety in the family. And besides that, there's also a pretty wide variety of pollination syndromes. So if you look at these ones here, starting in the top left, that's hummingbird pollinated, this is hummingbird pollinated. This will be pollinated by hummingbirds and bats. This one also by hummingbirds and bats. This one is pollinated by, I believe, tanagers. They're like a tropical sparrow-like kind of bird. And these ones are actually rodent pollinated, and also there are those green petals I was talking about. And these occur a lot at higher elevations, which another wide-ranging thing about this family is they can occur at sea level or at much higher elevations. And when you get up higher, the insects are less prevalent, and so that's when you get vertebrate pollinators that these folks have. very widely distributed. We've heard of regions like Africa and Southeast Asia and Australia today, and my plant family is pretty much all over the place there. You can see that the bulk of them, just over 2/3, occur in the New World tropics and extend up into the eastern United States. That's 69%, which is just over 3,500 species, I believe. And then in Africa and Madagascar, you have a further 10%, and, which is considerably less than the New World tropics. And in Southeast Asia and Oceania, you have the remaining 21%. But they are distributed throughout the world, all over the place, as you can see, which is what you call pan-tropical. And perhaps the most important reason why it's a good idea to build a key for the family is right now no global scale interactive key exists for the family. So that's a pretty good reason to build one. With so much diversity and with so many species, it's really important to have advanced tools for identifying them both in the field and in the lab. So there's a couple different types of keys. For the purposes of this talk, I'm going to lump them into two big general categories. The first of which being single access keys, which we're most familiar with, and Brett just had one in his presentation a few minutes ago, which is like dichotomous and polygamous keys. So a lot of you are probably most familiar with dichotomous keys. And there's one there on the left. And basically, you have like couplets and leads, and then the key builds on itself as you proceed through the key steps. And they've been around for a long time, for centuries. And they are very useful, but they have a couple of drawbacks, which I'm going to line up or talk about here. Their structure is very rigid. Like I said, it kind of builds on itself as you go. Each key step down, you are including the characters from the previous key steps. And you have to have those characters and go in that sequence to get a positive ID of whatever organism you're trying to identify. They can be weakened by having fewer characters in that way, because you need to have the characters that are in the key. And if you have characters that are in the key, you can't use them anywhere. They're kind of unforgiving by design, in that if you make a mistake somewhere along the way, because they are so rigidly structured and the key steps build on each other, you're likely to get a false identification. And one of the biggest things is that once they're printed, they're immutable. You can't change them. If you get new data or even new taxa, you can't just add those onto a dichotomous key. You have to rewrite the whole thing from the beginning because of the way that they're structured. And also, importantly, if the author of the key makes mistakes, then that will greatly mislead people using the key and, again, lead to false IDs, most likely. So those are a few issues with single-access keys. But there's a solution. The multi-access key, which is the sort of key I have built, they are usually digitized and interactive, which makes them easy to update when new data becomes available. You don't go through a unidirectional set of key steps to identify things, so if you find new information, you can just add it on without having to rewrite the whole key. And it's a lot more user-friendly. You can choose characters in any order. It doesn't matter what sequence you plug your characters in. And you'll all get a demonstration of this when I get to my key. You can select from any variety of available characters. There can be a wide range of them because they're not dependent upon each other for a successful ID. And they often incorporate visual aids and multimedia, which makes it a lot easier for people to use oftentimes. Like if you can have a picture of the character that you're trying to select for, it can make it a lot easier to make sure you pick the right state. So there are two primary programs that people use to build multi-access keys. The first one is Delta, Description Language for Taxonomy. It's kind of a tortured acronym, but we'll go with it. The other is Lucid 3.5. And Delta is free, and there are open source versions of it as well. And it's very widely used, and there's their website there. If you want it, you can always ask me later. Lucid is not free, but it's very well supported. They have a support team, which I can attest to. I've spoken to them several times. They're very helpful, and there's their website. If you want it, again, you can ask me later. For this project, we went with Lucid. And the good folks at Lucid have provided us with a very technical and detailed video explaining how the program works. So we're going to look at that real quick. I think there's sound, too. So I pause it. happy ending. So a couple of points with that video. One, Lucid looks nothing like that in operation. However, the principles are adequately represented. You do click from characters and it gives you. And the other thing I'd like to say is that you never are going to identify something with two choices of character. Oh man, that's terrible. So anyway, moving on. When I first came into this project, I had a few goals that I was going to focus on. One, I had to learn how to use Lucid. Go figure, I needed to learn how to use the software I was going to use to make these keys. And I had never used it before, and nobody here had used it before, or no one who I was working with. They had just purchased it shortly before I arrived, and there it was, said go figure out how to use it. So once I did figure out how to use it, I got to write a guide on how to use it, so that the people who come after me can more quickly continue the work that I'm going to be leaving behind. And then I had to actually create the keys. So the goal was to, as you may remember from earlier, there are 20 tribes, 19 or 20 tribes, over 170 genera, and over 5,000 species. So I was not going to build a key to species in my 8 weeks here. That wasn't very likely to happen. So the goal was to build a key from family to tribe, and then from tribes to genera. And again, I wasn't going to get through all the tribes, but I wanted to get through as many as I could. So here we're going to go through really quickly how to build a key. Step one is to acquire character data. I ended up looking at, this is a bit of an estimate, but it's probably short or low of anything, over 100 scientific publications. Every day I was looking through papers. They were always sending me new papers to look at, to find character data to use for these keys. And it wasn't enough just to have a lot of papers. There had to be more challenges than that. So I had papers in French. I had papers in Spanish. I had papers in Portuguese. And I had papers in Latin. On occasion, I got one in English. Those were good days. I'm told also that I was spared some German papers that I didn't have to deal with, so I at least have that to be thankful for. But did I mention I don't speak Portuguese or French or Spanish or Latin, because I don't. A little bit of French, but not really botanical French. So that was an interesting challenge, was dealing with all these different publications in different languages. But I guess that's something that happens pretty commonly when you're looking through a lot of literature, especially with this huge family that occurs mostly in the tropics. I had a lot of Portuguese and a few Spanish ones as well, primarily. So. Step two, you pick the characters you want to use and you import those into the program. Now, these numbers are actually a little bit outdated. I made this a couple days ago and didn't have time to update it. So here I had come up with 125 characters in over 400 states. The number is now probably closer to 150 and probably over 500 states. So I ended up putting a lot of characters in. And also I want to mention that these are all morphological characters. We didn't use any genetic data for these particular keys. None was actually needed for these keys, although it's possible that when they go to the species level, they might need to incorporate some of that as well. So, a lot of characters involved. Step three, once you import the characters into the software, you have to score them, which is when you actually pick the different character states and attribute them to the appropriate taxa. So, here's just an example screenshot of the key to tribes. So here are the different tribes listed up here, and then here are the different characters and states. And you can see there's a couple different colors of check marks, but basically, if a particular taxa has a state, commonly you give it a blue check, which is the most widely used one you can see. If it has that state, rarely you give it a green check, and if it has, and yellow means commonly misinterpreted. So there's options like that to make the key a little bit more user-friendly and a little bit more accurate. And what it can actually do is it'll rank the list of taxa that you might be keying out in order of what one is most likely to be it based upon things like those rare marks and stuff. So the software is very powerful and very, very intuitive, actually. So let's see. Step four, which really should be step forever because it never ends, is testing and revising the key. This family is still being very extensively studied. Darren is going to Vietnam tomorrow, right? Yeah, for another expedition. And there's always going to be new data coming in and probably new taxa as well. So, but like I said earlier, with the beauty of this kind of key system is that you can just you can add those on and it doesn't impact anything else. So you don't need to rewrite the key or anything like that. If anything, you might need to change what genus that some species is in, because that happens a lot. Things get moved around a lot. But you don't have to restart from scratch. You can still use the existing data, which is very, very useful. And also, that means you're always building upon what you've already done, which means that you're kind of always moving forward and never going back, which is really nice. Results and conclusions. I wrote the guide to the builder, which is pretty cool, has pictures. So if anyone wants to use Lucid, let me know. I'll give you a copy of the guide. I built the key from family to tribes, and I built keys for 13 of the 20 tribes, which accounts for about 50 of the 170 genera in the family. And those numbers might seem kind of odd. It's more than half the tribes, but less than a third of the genera. I'll explain that in a moment. But in the meantime, we're going to demo the key interactively. Not you guys, but Frank, because there's a lot of botanical jargon. So I also want to apologize in advance for the forthcoming barrage of compatible jargon. Just, don't worry about it. So, Frank, do you have a plant in mind?
Let's go for the genus Arthrostema.
Okay. So, where did you find said plant?
New World. Mexico is okay.
In Mexico. And what sort of habit does this plant have?
Herbaceous.
Okay. And I want to pause here and point something out. As you can see, the list of taxa that could potentially be correct grows smaller each time you choose a new state because you're eliminating taxa that don't have those character states. But alternatively, which is a neat feature, you can switch this over to where instead of giving you yes or no, it fits these characteristics you put in. It scores them with a percentage. So, for example, all these taxa here fit what we put in 50%. So this could be very useful if you did eliminate all the taxa on the list. You could see what was closest to what you were keying out. So this is actually a good way to compensate for key builder error. If I had made a mistake somewhere, you would at least see that any particular taxa you're looking at is really similar to what you're looking at. So if I were wrong about something, you would still at least know that that was very close. You can investigate the matter more easily. But anyway, carrying on. Sorry, I'm like sideways. It's weird. So if it's herbaceous, the substrate is terrestrial or lithophytic?
Terrestrial.
Terrestrial. And is the leaf arrangement opposite?
Opposite.
Okay. Opposite is by far the most common state in this family. Actually, I'm going to switch this back. And does it have styloids or megastyloids?
Absent.
Okay. And florobracts, is there one or two pairs?
Two. No, one pair, sorry.
Okay. And how many petals?
4.
See, it's time to get grim. We're not losing any taxa. Flower sexuality?
Perfect.
Okay. That means it has male and female parts, for those of you who don't know. What type of inflorescence is it?
Sign.
Like a simple sign?
Simple sign.
Okay. And position?
Terminal.
Terminal. There's a button that extends all of them. I'll just press that. Much better. All right, and does it have an anthrodorsal gland?
No, it's absent.
Okay. And the anthers are by pores or slits?
Pores.
Okay. Bear with me, guys. We're almost there. I promise. And the ovary position?
Superior.
Yes. See, I'm glad someone's into it. Ovary locular number?
4.
4.
Position, I don't know.
I'm glad.
Got rid of one.
We're almost there. And we're running out of characters, so I think we can get down to 1. And the ovary apex, CD?
Absent.
Absent. Flower, okay, that's isomers.
Isomers.
Staminodia?
Absent.
Seed size?
Less than 5 millimeters.
Okay. And this should be a good one for eliminating some taxa, guys, so get excited. Seed morphology?
Cochlea.
I lost the mouse. Almost there. And the seed testa.
Caustic.
Ta-da! So now we've gotten it down to the. So now we have eliminated all but one of the taxa. In this case, this is the Tribrexii. So but the key right now is built in this way, so that you can click this, and you can either click here, and it'll give you a description. Oops, I lost it. Let's click on it again. It'll be easier to go and look for it. And it'll pop up a window with a description that's generated by the way that the key is programmed for this particular taxa. And there's also this handy link that takes you to the next step of the key. This, by the way, is hosted on a friend of mine's web space. That's why the URL is like something about coffee. It's not really official. So at this point, you're going to have to repeat a lot of the things you've put in just because of the way the key is structured right now. I'm trying to figure out if there's a way to actually incorporate everything at once, and I haven't figured that out yet. So hopefully someday it'll be able to retain the scores you've already put in. But there's a good chance that now that we know what tribe we're in, that we'll be able to get to the genus without having to go through as many characters. So I'm just repeating, oops, wrong button. It's an herb, not a shrub. It was herbaceous, right, Frank?
Yes.
I was like, yes, good at it. And it was terrestrial. And it was terminal inflorescence.
Terminal.
And it was a simple sign. Now I said we should be able to get there with fewer characters, but perfect. 4 petals. Ovary position superior. Ah, there There you go. And that was the genus you had in mind, right?
That's it.
Okay, so it works. Hooray.
Show me the picture.
Sorry, that's it. Huh? Oh, that's right, sorry. The key incorporates, this is a much better description because it's not at the tribal level, but at the actual generic level. So this has a description of the characters of the genus based upon how the key is programmed. So if you added more characters to the key and then scored them, that would automatically be added to this description. So that's pretty useful. And you can incorporate multimedia. Click on this. Somewhere there's a picture popping up. I promise. But I'm having probably pop-up blocker issues. Oh, there's the picture. It's on the wrong monitor. Ta-da. So if you were on a regular computer, it would just pop up right in front of you and wouldn't have been such an issue. But anyway, so that's how the key works. And see if I can get my PowerPoint back. I guess Chrome does this thing where it's like somehow no. There, right. So that was how the key actually works. And you can also incorporate pictures for the characters and states so that you can click on, like, remember in the video he had what the leaves look like? I could actually have pictures of different characters that people could click on. So you can incorporate those. There were just a lot of different characters and states, so it would have been laborious to get all those pictures. So the further work needed is, of course, the keys for the rest of the tribes need to be built. Now, you remember earlier that I had done less than a third of the genera, but over half of the tribes. 2 of the remaining tribes alone contain a further 73 genera, which would get you back, or up to over 2/3 of the genera in the family. And on top of that, the most speciose tribe is called Myconiae, and it's possible that it's going to be collapsed into a single genus soon. Is that right? So there's going to be a lot of changes as more studies done on the family. So it might not be the most practical thing to build a key for it right now, when there's still, for those particular tribes, when there's still a lot of work, and they're probably going to be divided up and or condensed into smaller groups. And like I said earlier, revision and testing are ongoing requirements, especially when you're dealing with a family that has thousands of species, as opposed to dozens or even hundreds. I'd like to acknowledge, of course, my advisors, Dr. Pennies, Dr. O'Neill, Dr. Fitch, the Lucid support team, who, as I mentioned, helped me out with a few things, especially early on, the Academy of Sciences for hosting us this summer and being a wonderful place to work, the MSF Melastomataceae Phylogeny and Biogeography grant, which is what is funding a lot of the research that my advisors are working on, as well as, I believe, the purchasing of Lucid in the first place. The curators and my fellow interns who gave our lectures and led the field trips and everything, and of course Kristen, who's neither of those things but fits into that list. And the National Science Foundation for funding this whole program in the first place. And at this point, I'd be happy to field any questions that you might have.